Today is a very exciting day as NASA's Perseverance rover lands on the surface of Mars in Jezero Crater. Hello and welcome. My name is David Weigel, and I'm the Intuitive Planetarium Director here at the U.S. Space and Rocket Center. And today I'd like to give you a quick heads up as to why you should be excited for NASA's Perseverance rover, and not just the landing, but also the upcoming mission here over the next several years. And to do so, I'd like to bring in some of our friends. First, Dr. Caleb Fassett, who is a planetary scientist at NASA Marshall Space Flight Center here in Huntsville, and also Alex Mather, who actually won the naming contest from NASA to name Mars 2020, which is now the Perseverance rover. So let's jump right in. The Perseverance rover is exciting to me because any chance that we get to send a spacecraft not only to another planet, but literally down to the surface is a moment worth celebrating. And Mars in particular is a very interesting place because it's probably a world that was once rather like the Earth, far, far back in its past. Now, today it certainly isn't. It's a cold place, it's a very dry place. It's a world that is akin to some of our pretty extreme deserts, but with maybe a lot more radiation and a lot less air. However, all of that said, as we explore Mars more fully with missions like Perseverance, we can better understand not just Mars, but try to answer questions like, is there life on Mars? Was there life on Mars? Or could Mars have been habitable in its past if life was given the opportunity? And so as we strive to answer these questions and many more, we're also paving the way to not just send robotic explorers in the future, but also human ones. And it's not a stretch to say that the first person who will walk on Mars is already alive. So we're very, very excited for this opportunity to dive down closer into Jezero Crater and explore it on, much more attainable scales to really see what it looks like and try to better understand this ancient river delta. Now, with looking at a river delta, this really gives us a prime opportunity to explore this potential of past life on Mars. Life on the Earth is really abundant in river deltas, and we have one that's extremely well preserved, as you can see here, with our rendering of Jezero Crater using imagery from the Mars Reconnaissance Orbiter and elevation mapping as well. Now, as this landing unfolds today, the rover is going to be hurtling through the atmosphere, traveling about 13,000 miles an hour, getting down to zero. The entire process is going to take about 7 minutes, and due to communication delay, due to extreme distances between the Earth and Mars, we're not going to know whether it is alive or dead for 12 minutes from the beginning of its entry all the way until it has been landed on the surface for about 5 minutes. That's when the signal will return to us. So we have a very, very exciting opportunity to experience this afternoon, and fingers crossed that it all goes well. So to hear a little bit more, now let's turn to Dr. Caleb Fassett, again, who is a planetary scientist for NASA's Marshall Space Flight Center. So, as a scientist who studies Mars every day, when you're trying to study something on the Earth, right, you can just, as a geologist, go to that location of interest, and that's relatively easy to do, to sink your hands into something that you're trying to study. But of course, on Mars, we have to get data from different spacecraft. So what does it mean to you to have this opportunity for a brand new rover down on the surface that is landing today?
Yeah, so it's a huge thing, right? Because if you think about Mars, even though it's smaller than Earth, it's still a pretty big place, and the total surface area of Mars is the equivalent to all the continents on Earth. So it's it's like if you land on 5 or 6 or 7 places, ultimately, even with amazing robots, you can only explore a few places if you think about the scope of the planet. And Mars is also incredibly geologically varied. I love practically every bit of it. But this particular landing site is special to me because I saw it for the first time nearly 20 years ago in orbital data. And the fact that we're going to land there is very emotional for me because basically it's a realization of 20 years of thinking about a location and being able to then see it with at human scales. Even though it's with a robot, even though it's tens of millions of miles away, it's still going to be rendered to us with ingenuity and perseverance at human scales when we're there. So it feels like a major gift in my life to have this place be selected and to have the world exploring it starting today.
Absolutely. So let's talk about that a little bit too. So you discovered Jezero Crater, and now the entire world's eyes are going to be on that. But taking this back a little bit, if you could tell us a little bit about how you came across this one in particular and what you initially saw.
So one of the great things about being a scientist who's been looking at Mars for a long time is we've had a fleet of orbiters that have been giving us data of basically the whole planet. And the Mars Odyssey spacecraft in particular, which is still active, was relatively new in 2003, 2004, when I started looking at this region. And what stood out in the Odyssey data set was the fact that this crater had an outlet in Themis data. So it's a crater, there's valleys that come into it and out of it. And the fact that we could see that from orbit, even with, at the time, relatively low resolution data, meant that it had potential to be a lake. Then we got topography data to compare it to from an instrument called MOLA, which was on the Mars Global Surveyor, another one of this orbital fleet. And MOLA showed that the outlet was perched way above the crater floor. And so to have that outlet ever form and flow, you have to float up to the level of that outlet and overflow, basically have a big flood. And so those were the two things that stood out initially. I also, in the Themis data, saw the hints of the delta that you can see in the western rim, which is actually the main subject of Perseverance's mission. And so those things were all recognizable in 2004, and that's why I wrote this initial paper.
Awesome. Yeah, I think, when we show this off in the planetarium, it really is astounding. And it's very obvious, even to, the untrained eye, that at least once you tell them that, yeah, these are inflow rivers, these are outflow rivers, that makes this probably a lake, and people get on board with that very quickly. So there's not a lot of, surprise there in particular.
Yeah, one thing I'll add about that is that, at the time I was almost an untrained eye, which might have been an advantage because I was a second-year graduate student when I started working on Jezero, which wasn't even called Jezero at the time. Obviously, there's lots of craters on Mars. It didn't get its name until after it became a subject of interest. So.
Very cool. Actually, yeah, that's definitely good to point out. But I guess a follow-up of that, Jezero crater was just one of very, very many craters that was initially proposed for Perseverance. And obviously you thought that it stood out, but I guess what in your opinion really lends itself to Jezero crater as opposed to all of the other, potential landing sites?
So when you're picking a landing site, one of the things you have to do, besides establishing that it's going to be safe to actually land, is basically match the landing site to the science objectives of the mission. So Mars 2020 and now known as Perseverance's science objectives are really to look for signatures of ancient life, biosignatures, and to find those on Mars, which is, as we know, a cold, dry place now, is tricky. And so you have to pick places that might preserve a record of those. And so one of the things that we know from Earth is that environments where water concentrates sedimentary rock and basically precipitates minerals like carbonates, and also deposits minerals like clays, are good places for looking for biosignatures like organic matter. And so in my initial work, I made the case this was a lake, but after that, a bunch of other very clever people recognized that there was signs of these carbonates and clays in this crater and in the delta itself, using the CRISM data aboard Mars Reconnaissance Orbiter. So there's a one of the things we can do with our orbiting spacecraft is take images in other wavelengths of light besides what your naked eye can see. And so CRISM looks in the visible wavelengths, but also in the near infrared, so longer wavelengths than your naked eye can see. And so at those wavelengths, these minerals stand out. And so the discovery of those is one of the real reasons why Jezero sort of stood above the rest of the pack. There was both this exciting lake environment, also this mineralogy, which is very exciting. And the combination of those two things is why it was picked.
Yeah, that's awesome. And, I guess what people sort of forget about, I think, with sending a rover down to the surface is, they get really excited for all of the pictures, but maybe not, the rest of the science that's involved that really, motivates these decisions in the first place. And so I think it's really good to point that out. Now, on that, you mentioned that there's a pretty diverse really environment to this crater, in that you've got kind of the lake bed area, the river delta, and then sort of further up on the cliff. I guess, can you put into perspective a little bit for people the sort of, I guess, sustained excitement that we'll see throughout this mission as it continues on?
Yeah, so obviously we don't know where the rover is going to go yet, or even exactly where it'll set down. Ultimately, there's a lot of hope that we'll explore the delta, we'll explore all these different mineralogies inside Jezero crater, basically doing field geology with all the instruments aboard the rover. But there's also hope that eventually we may get up on the rim of Jezero, which is very ancient rock, very early in Mars history, and then even beyond and outside Jezero, where there's incredible stuff outside the crater itself. So there's been a debate in Mars astrobiology about whether you want to look for the signs of life in surface rocks, like the delta. Delta was deposited near the surface in these standing body of water, or in deep rock. So rocks that basically are in the crust and now exposed because they've been eroded and now exposed to explore. And the rocks outside Jezero are actually these deeper crustal rocks. And so there's hope that you would actually be able to explore potentially both these habitable environments if we start inside Jezero and then traverse outside the crater itself. This crater is really, really cool because if you look in its walls, you can actually see exposures of the interior of the delta. So when you think about outcrops of rock, layered rock on Earth, often it's tricky to get a three-dimensional perspective of what's underneath you, because if you have a relatively low angle exposure. But this wall, especially the wall that's nearest us here, actually exposes both flat-lying rock and also rock that are inclined at an angle. And so we think those are probably areas where the channels that were on that deposited this sandstone that makes up the delta were actually migrating across the surface of the delta deep in Martian time. And so I want to see that when we rove, my hope, my dream is to see what these sedimentary rocks actually look like in human scales. I have some ideas. I have some mental pictures of what they'll look like, but I'm not totally sure.
So could you speak a little bit more to your role in the Perseverance mission?
Yeah, so my role is a lot like many of you in the general public. I'm going to be following along with bated breath. I'm not actually on the mission team. I'm going to watch what they do. It's going to be really cool. And I'm hopeful it'll be really exciting for all of us to follow along. So it's not going to be my day job, but I'm really, really thrilled to follow along in the daily updates that the team's going to produce.
Fantastic. And then maybe last question is, we've got a very exciting addition with the Ingenuity drone that's going to be flying alongside Perseverance, and literally flying. It's going to be the first drone to fly on another world, we hope. And what does this mean for the future of exploration of other worlds?
Oh, it's super cool. I mean, obviously, Ingenuity is a bit of an experiment. It's a tech demo, so we hope it works. I think it'll be really nifty to see Mars sort of from the drone scale, like we have commonly see parks and beaches and things on Earth when people fly drones. It's a really, really neat exploration path. One of the things I will say is that there is hope in the next few years to fly on a different world, Titan, with a mission called Dragonfly, which is going to fly a very, very capable drone on this moon of Saturn. And so Ingenuity is first, but it won't be the only time we fly on another solar system object. I don't think. I think it's just that just getting started. And I eventually hope we fly in Venus's atmosphere too. That'd be really cool. You could do balloons. You could do a variety of different approaches to flying on Venus, which is a very thick atmosphere.
Yeah, that sounds awesome. Absolutely. I mean, that then makes literally the sky, not the limit anymore, and you can go anywhere. So super exciting. And for me, I think having something like Ingenuity able to, or sort of an Ingenuity on steroids, able to have perhaps like packs of these drones, survey around different planets, just the possibilities start going, through the roof. And that's really, really exciting to me. Is there anything in particular about this mission that, and Mars in general, that you think, the standard person should know and should be excited about?
I mean, I get excited about Mars and a little bit emotional about it because it's kind of another landscape to explore, and where we can explore processes that happen on Earth, like volcanism and impact cratering and the wind and water and glaciers, and the weather, the climate, all these things. It's another laboratory for doing that. And so I basically, it's hard for me to pick one thing because I get pretty much excited about all of it. But I will say it's going to be really hard to live there. Humans, human missions are something that we hope to do as a country in the next coming decades. But it is going to be hard because it's cold. There's not a lot of air to breathe. It's going to be a real life support challenge, and it's far away as well. It's a long trip from Earth. So even though I'm just enamored with the planet as a place to explore and learn about processes that happen on Earth in another place, I don't expect many of us to move there anytime soon. Even though I hope in my lifetime we do get to explore it with people.
We now have Alex Mather, the winner of NASA's Name the Rover essay contest, who actually named the Mars 2020 Perseverance rover. Welcome, Alex.
Thank you for having me.
In thinking about Perseverance, I was wondering if you could put into perspective what it feels like to see the rover that you actually got to name land on Mars.
To try and put you in my shoes, imagine if you enter a contest to try and help NASA, and when you win, it changes your life forever. That emotion right there has been building up for almost the past year, and it's incredible.
What was your motivation to enter the contest? And by that I mean, what was your thinking in even entering in the first place?
The largest space agency in the world called out to American students like me, saying that they wanted a name for their newest Mars rover that was going to study astrobiology in a river delta and potentially find evidence of past life on Mars. And maybe, just maybe, I could have an idea in there that they might consider. And just the idea that I will get to participate in this mission, even a little bit, by submitting a name at all. That really caught my eye. But I definitely want to make sure that the name I put in was the best it could possibly be.
Did you go through a lot of different names before settling on Perseverance specifically?
I remember teamwork was the big one before I thought of perseverance. There was strength, there was ambition. I'm very glad I landed on perseverance when I did, because I definitely feel like that name fits.
I agree too. If you could elaborate a bit more, what does the name Perseverance mean to you specifically?
There was a story that I was told as a very small child. I don't remember what I asked, but I do remember what my parents told me, which was that there were a lot of human-like species that were similar to us, but the world was changing and there were a lot of mass extinctions and natural disasters that wiped a lot of species off the globe. But humanity persevered and survived, and that's why we're here now. And all of human civilization is stories of humans persevering and overcoming adversity and working together to accomplish incredible things, because all of these obstacles are just things in our way that we can get over and we can still reach our goals. And that story of humanity is really what perseverance means to me.
That's really powerful and awesome.
Thank you.
What in particular about this specific mission are you most excited about?
Ingenuity. They're gonna fly a helicopter on Mars. A year ago, before I had heard about this, if you had asked me if I was ever going to say that sentence, I would probably say no. But that's not even it. There's Moxie, which is going to be producing oxygen from the CO2. There's Sherlock and Watson, which are going to be both collecting large amounts of samples, which will be brought back to Earth in the future. Also really cool, by the way. And then examining them to get all kinds of crazy data. There's so much on this rover that, honestly, I don't think I can choose a favorite. It's all ridiculous. I don't know how NASA does it.
Is there anything about Jezero Crater that you're particularly curious and excited about?
There used to be flowing water on Mars. Curiosity discovered that. And river deltas on Earth are places with tremendous amounts of life. Bacteria, plants, fish, everywhere. You name it. If there is life on Mars, it will probably be on a river delta. And a major river delta like Jezero Crater, if there's going to be fossilized bacteria that we're going to find, it will probably be there.
Now, switching gears a bit, maybe tell us a little bit about your time at Space Camp and how that influenced you moving forward.
I wasn't uninterested in science. I definitely did have an interest, but I would say that I didn't really have any direction. And then Space Camp happened, and now my scientific passion has a direction. And I'm grateful for that.
You know, with this newfound direction, what can we expect from Alex Mather in the future? Do you want to be an astronaut, an engineer, a scientist, the next Mars Rover chief engineer? What are you thinking?
First up for me right now is to get into the science and technology school that I applied for high school. And then 16 is the age when I am qualified to apply for NASA internships. And I live near DC, so fingers crossed I can get one at the headquarters. I want to do whatever NASA needs from me. Where can I help the most? Where do they need me the most? That's what I want to do.
And finally, what do you want people to be thinking as they watch the landing here today?
I want people to be thinking about everything that led up to this point. It was 10 years ago when NASA decided that they wanted to make an astrobiology mission, a rover that was going to go to Mars. there was all the engineering that had to happen at JPL and all that hard work by all those people. And then the launch, and then the trip where they just were powering everything on and then off just to make sure that it worked. And now the landing. 10 years of hard work by some of the best scientists and engineers in the world, leading to this and hopefully leading to more. And that's what I want people to be thinking about.
Alex, it has been such a pleasure talking to you. Thank you very much, and go enjoy the landing.
Thank you for having me, really.
As we wrap up our live stream for today, I want to thank you for watching, for one, and I'd like to invite you to explore further with us in the Intuitive Planetarium. You can join us every single day here at the U.S. Space and Rocket Center and on Friday evenings for special programming, particularly tomorrow evening, as we take a more in-depth look at the Perseverance mission. I'd further like to thank Dr. Caleb Fassett and Alex Mather for joining us today, and I'd like to invite you now to tune in to the NASA live stream to watch this momentous and very exciting landing. So stay excited, and fingers crossed all goes well.